this one, obviously, because it's multiple choice, I don't need as much as I would on one that's not multiple choice. So number 1 and 2 are basically the same problem, but just different things that I'd be looking for. If you want to put this one in your calculator, what are we going to have to do? Solve for y, okay? So that's probably my go-to here. You got to see what the graphs look like so you can match up the graphs. And probably the best option would be to solve for y, put it in your calculator, okay? If it's already solved for y, we're in good shape. If not, we need to get it there and see what the two graphs look like. And then just find the intersection on your calculator. This one does not actually ask for the intersection. And so you're just looking at which one matches up with the two graphs. Most of the time we're looking for the intersection of the two. I think I went ahead and wrote what the intersection was, but it's not actually listed on the multiple choice. This one's the same thing, except you have to do all the graphing by hand, okay? And then tell me what the solution would be. So the key here is solve. If it crosses, tell me what the ordered pair is. If it's parallel, tell me that it is no solution. If they are right on top of one another, then it would be infinitely many solutions. So don't just graph it, make sure you tell me what the solution is as well, or what type of solution it has. Number 3 is the same way. Okay, and I'm not telling you that you can't use your calculator on these, but if you do use your calculator, you got to make sure that when you graph it, it's accurate so it crosses at the right spot and those kind of things if it crosses. So just some things to be aware of or be careful of. Okay. On numbers 4 and 5, you got to do substitution. Okay. And on these two, kind of like I told you guys the last couple of days, I will be looking for the work to show substitution. So you can't just put it into your matrix and get the answer. If I don't see any work showing substitution, you're going to miss some points, okay? Just fair warning you, I do want you to use substitution to get there. Can you use your matrix to check it? I don't care, but once again, I would just need to see the work that shows substitution, okay? Elimination, same thing, 6 and 7, show me the steps for elimination. And like it says, if you want to use your graphing calculator to check it, either by graphing it or by doing matrices, I don't have a problem with that one bit, but I do want to see the steps showing elimination, okay? So just make sure, do the method. When it says this is the method they want us to use, that's the method I want to see. There will be some here that it won't tell you what method to use, so you can use whatever method you want and choose the easiest. Okay. There are 3 different types of systems, but there's 4 choices here. Okay. I'm going to go through and talk about the 4, which one's which, and it may not always be in this order. So we got to make sure we understand which one's which. Consistent independent is one solution. That means they're going to cross at an ordered pair. Inconsistent independent means the two lines are independent of one another, but they don't cross one another. Okay, so that would be 2 lines that are parallel. That would be my no solution. Consistent dependent is infinitely many solutions. So there is not ever going to be one that's inconsistent dependent. So that's the one that we will never have. So that one would be always eliminated. Then we just have to decide which one it is. Okay? For me, I think the easiest way to do this one is solve for y. Solve for y, compare the 2 equations. If they have different slopes and different y-intercepts, then we know they're going to cross at some point. If the 2 are exactly the same equation, then we know it's infinitely many solutions. If they have the same slope but a different y-intercept, then we know it's no solution. Okay? So once it's solved for y, you should be able to tell pretty easily which solution I have. You do not have to solve it, you just have to tell me what type of system it is. And that goes all the way back to the very first lesson when we talked about the three systems and what each one is. Okay. So you could put it in the calculator, you can do whatever you want, but I mean, you could even put this one into your matrix if you wanted to, and see what you get for your solution, and then that tells you what type of system you have. There's a lot of options there, okay? But for me, I think it's easier just to solve for y and see what kind of equations we have. Okay, on this one here, there's a couple different ways to handle this one. I'm going to show you kind of an easy way to go about it. And number 9 and 10 are essentially the same type of problem, different information, obviously, but ideally it's the same thing, just different ways of expressing an answer that represents some type of situation. So on this one here, we've got these handles that we're making at this factory. They're molding plastic handles and they cost 30 cents per handle to mold. The fixed cost to run the machine is $4,098 a week. If the company sells the handles for $330 a piece, how many handles must be molded and sold weekly to break even? Okay. If I ever run a business, there's two things we got to keep track of. You got to keep track of your expenses and you got to keep track of your profit. And I want to figure out what's going to break even, right? The goal of any business would be to break even. And if I'm not breaking even, then I got to figure out what I got to do to break even. Otherwise, I'm not going to be in business very long, right? And so your profit has to exceed your expenses in order for you to make a profit, okay? Or to make some money. So in this case, first of all, X is the number of handles that I'm either making or selling, depending on which you're looking at. Okay, the expenses, the outgoing. Each handle costs 30 cents to mold, and the machine costs $4,098 a week. So we're looking at a weekly cost here. Would be and it's 30 cents per handle. So that would be my two expenses. $4,098 is like just a fixed expense. For the whole week, it costs that much money to run the machine. And then it's 30 cents per handle. So those are both expenses. Okay, my profit, once I've got the handles molded, then I'm going to sell them. And we can sell them for $3.30 a piece. And what I'm looking for is what's the break-even point? How many handles do I need to mold and sell in order to break even? Obviously, I would want to do more than that to make money, but right now we're looking for the break-even point. So we're looking at when are these two going to be equal? So what would be the easiest way to solve to make these two equal? You could graph it, okay? Now, the only bad thing about graphing it here, we've got a fairly large number here, so we're going to have to change our window or zoom out or something like that, okay? There would be a way that I think would probably be a little bit easier, and graphing's not bad, but it's just because of the bigger number that I would probably stay away from graphing. Yeah, substitution, because both of these are already solved for y. So what I could do is I could take this right here, and I could put it in for y over here. And so essentially I could say $3.30 X equals $4,098 plus 30 cents X. The expense equals the profit. And then just solve for X. Okay. Should be, I mean, it's just a two-step equation from there. Okay, number 10, and this is where you could graph it and you could find out where they cross, and that's what this graph is doing, okay, and it's already been graphed, so we don't have to decide what method we're going to use. They give me two functions. This is the revenue, and this is the cost, okay? In this case, it's the same thing, except instead of handles, we're dealing with binoculars. We're going to make binoculars, we're going to sell binoculars. So X is going to represent the number of binoculars that we make and sell, and then y is gonna represent the number of money, or how much money it's gonna take to produce those, and then also how much money am I making. Okay, so the revenue is 3x, the cost is 1,500 plus x. This right here is the break-even point, okay? The x represents the x-axis. So x represents binoculars. Y represents money. So you got to pay attention to the question. Okay, it's kind of like last chapter when we had that one with how many years did it take for the population to be the same? So we got to read the question carefully, right? And in this case, the question is asking us, at the break-even point, the cost and revenue are both what? Well, cost and revenue is money, right? And so it doesn't just come right out and say, what's the money? It just says the cost and revenue. Cost is a dollar amount, revenue is a dollar amount, so we're looking for the dollar amount. If they wanted binoculars, they would say, at the break-even point, how many binoculars do I need to make and sell to break even? And so it just depends on which question is being asked. So in this case, the break-even point is $22.50, and that would be the cost and the revenue. And so really what we're saying here, if I make and sell 750 binoculars, I would make 2,250, and that would get me to break even. If I wanted to make money, I would have to sell more than that. Okay. Questions on either one of those? Okay. Number 11 and 14 are very similar types of problems, except number 11 is a 2-variable equation, and number 14 is a 3-variable equation. Okay, I'm going to help you kind of get number 11 set up. We did one like number 14 yesterday, so I'm going to try to let you guys set that one up on your own and work through it. Number 11, we have two different, and this is kind of like the one we did yesterday as well, except there's only 2 variables. We have 2 different loans. One's at 9%, one's at 5%. And it doesn't matter which one's X and Y. But I do want to identify which one's which, so when I get my answer at the end, I know that the X represents the 9% and Y represents the 5%, because the only thing that we're looking for here is the 5% one. We're not asking for both. When we get an answer, we'll know both, but they're only asking us for the 5% one. Okay, total loan borrowed is $17,000. So this student has borrowed $17,000 from these two banks or lending institutions for college expenses. So the total amount that I borrow was $17,000. So that's like my total amount. Okay, and then yesterday we talked about interest. The total interest that I get charged is $1,130 in the first year. And for the first loan, I'm getting charged 9%. For the second loan, I'm getting charged 5%. And my total interest is $1,130. Okay, because I only have 2 variables, I only need 2 equations. On number 14, you're going to have 3 variables, so you're going to need 3 equations. That's the only difference between the two, really. Hey, it doesn't say which way to solve this. So if I had to choose which way to solve this, which method would we use? What would be the easiest? Matrices. By far and away, the easiest. Okay. I wouldn't graph it. I wouldn't do anything else. I would just put it in my matrix, kind of like we did yesterday. And this would be a 2 by 3. Put it into your matrix as a 2 by 3. And then the numbers on the right should be your ordered pair. But we're not looking for the ordered pair. We're just looking for the 5% loan. So we're just looking for the Y value. If you need help with your calculator or you're not sure about matrices still, let me know. Today's the day to ask questions. Don't ask me in the middle of the quiz tomorrow, because I probably won't show you much. You need to know how to do that. 12 and 13 are just calculator problems. Here's what I would tell you is B and C, these are both representing IMS. So don't worry about the difference between B and C. So for your answer, you're either going to put A, infinitely many solution, or no solution. Okay? You don't have to worry about the difference between B and C. Morning. Hey, 15 should be pretty straightforward. What's the size of the matrix? That's all it is. Okay? You don't have to, there's no solving or anything like that. (16) and 17, this is what we talked about yesterday. This one gives us the equations. We have to identify which one of these matrices is the matrix that represents those equations. This one gives me the matrix. I have to identify which equations represent that matrix. So both directions. Give you the equations, what's the matrix. There is no solving there, okay? That's yesterday what we talked about when we talked about an augmented matrix. That's all you're doing there. And then the last one is the one that we did yesterday. And this is not a matrix problem. This is one that you do in your stat, in your calculator. And we did one of those together yesterday. It's also only asking for the C value. So when you do your stat and you type all that information in, it's going to give you an A, B, and C value. So pay attention to which one it's asking for. In this case, it's asking for C. So you don't have to write the entire equation out. You just, the one we did yesterday, we went and rewrote the entire quadratic equation. Okay. So if you need help with your matrix, let me know. If you need help doing a problem like that, let me know. Those are all just calculator type problems. You don't really have to show any work on ones like that. But the ones with substitution, elimination, and graphing are the ones you do have to show a little bit of work.